This video is going to be a basic overview of circuits and some elementary electrical concepts like voltage and current, and we're going to go over some basic analogies on how you can look at circuits and hopefully make it a little bit easier. So I want to start by going over some of the basic elements in a circuit and what you'll probably see whenever you're doing circuit analysis. The first one I'd like to touch on is a voltage source. Now you may have seen these in diagrams represented as a plus minus with a circle, or maybe two lines like this with a plus minus. They're the same thing. The concept here is that there's a positive voltage here and a negative voltage here, and this difference in potential energy drives the current. So here's the analogy that I like to use whenever trying to analyze these and understand them. You can view these very simply as a waterfall example or a water tank example. So let's say there's a water tank. Let's draw got a little square here to make it better. Let's say you have a water tank and it's filled with, of course, water. Oops. Yeah, we'll keep it like that. So here's your water up here in the tank. So let's say we have a hole in the tank that we put right here. So what would you think would happen when you put a hole in the bottom of the tank? Obviously gravity is going to take hold and the water is going to flow down. So this is a very similar concept to what current is and how voltage works with current. You can view voltage as this potential energy of the gravity. Like here's your tank, and let's say here's the ground right here. So the gravity is pulling this water down towards the ground. Same thing with the potential energy of the voltage source pulling the current through the circuit. So an analogy there is that the gravity is acting as the driving force of the energy, and that's what creates this potential energy of the water at this point, since it's being held up above the ground. Same thing with voltage. The current analogy is obviously the water flowing down out of the tank, but we're going to touch on that a little bit later. Second element I'd like to go over is current. Change this here. This will make a little more sense once we kind of get it all in a big circuit too, I think. So, a current. Current is essentially just the movement of electrons through wire. So let's say we have our voltage source again, and we have it connected to some sort of load. This load is just the resistor, and all that resistors are just elements in the circuit that impede the flow of electrons. The way I like to look at them is, let's say you have your water tank up here that we had before. Let me grab it. So here's our water tank from the last example. And let's say instead of just letting the water fall down out of the tank, we connect it to a pipe. So here's our pipe. And obviously you're going to have some pressure because of that water in the confined space. But here's your water flowing down the pipe, and right now it's going pretty good. So this flow of water you can call current. This movement of the water due to the gravity or the potential energy, aka voltage. So let's say in your pipe you have a constricted area. Let's draw it like it narrows. That's a terrible drawing. Here, like that. Kind of narrows down. So what do you think is going to happen when the water flows through this smaller area? It's obviously, there we go. So there's going to be less volume of water flowing through this constricted area here, and this is an equivalent to a resistor right there. So what happens is your current's flowing here. Your current can be defined here in this analogy as like the amount of water flowing through this given cross section of the pipe. since your pipe is much smaller, it constricts that cross section to a much smaller area. So you're not going to have as much water flowing through a given section of pipe as before, ergo a lower current. And this relationship can be defined by Ohm's law, which is a very important fundamental relationship between these concepts, where your voltage, here's your voltage, is just equal to a linear relationship between current and resistance. So in this example, your pipe becomes smaller, so that means resistance goes up. And that means that if your voltage, did anything change with the voltage here? No, nothing changed in the voltage. Your voltage is just gravity. Like, this is not going to be affected by anything going on in the pipes. Your voltage is going to remain the same. So, since this element, I'll draw this in green, since this guy is the same, this hasn't changed, but your resistance has increased, that means that to keep this the same, your current will have to decrease. So that's a good way to analyze this and look at it from that perspective. Another note to make here is, in this circuit example I made here, this wire, let me get a little color here. Let's try red. This wire that I drew here is just the same as the pipe. The pipe is the wire. It allows the electrons to flow because of the metallic bonds, and all the electrons flow freely through it. So the resistance in the wire you can treat as almost nothing, same as the resistance in a pipe, really. There is some, I guess, because of the pipe walls, but at the end of the day, it's really negligible. So that's a basic analogy of that. Let me try and tie it all together here in a basic circuit here. So let's say you come across this with like 5 volts, and you have a resistor. Whoa. Let me draw that. There's a squiggly resistor. So let's say this is 1 kilo ohm. So this is analogous to, let's say here's your water tank with some water in it. And then it flows down, through your pipe, and we'll constrict it. Oops. Yeah, get the idea. And then there's the ground here. So I'm going to label these elements on this example here the same as they are in the circuit, even though it's really not a resistive thing. This is similar to the 1 kilo ohm resistor, and this here is similar to 5 volts. So this potential drop is the same as this potential drop, and this is the same as your constriction in the pipe. So we can use the concept of Ohm's law here to find what is, let me draw this in a different color, what is this current across this resistor based on this voltage. So we just use our basic equation, V equals IR. We know our voltage is 5. We don't know our current, and we know our resistance is 1 kilo ohm. So I is 5 over 1,000, 0. So this is in amperes, and that's how you define the current as units, and that unit is in amps, which is just an A. So that's a basic introduction. In further videos, I'm going to go into a little more depth on circuit analysis and how we can elaborate on these principles and have a better understanding.